Good morning, stargazers and songwriters and electronic artists and recording engineers. I wanted to go over a subject today that has been baffling me for quite some time. I'm almost embarrassed that I didn't understand it before, because I remember in several recording courses at community college, at state, and on Coursera through Berklee College of Music that I had learned what gain staging was, in the sense of being able to cascade different gain stages or points in a series of gain elements, and how they behave and what they do and how they affect the sound quality and sound character. I have Juice open, which is an integrated development environment for software programmers in the audio department. And I was viewing this demo of an overdrive pedal or an overdrive effect for software. So this wouldn't be the use of vacuum tubes. This wouldn't be the use of bipolar junction transistors, not JFETs, and not even MOSFETs or metal oxides semiconductor field effect transistors. But this is digital distortion, digital overdrive. And I'm looking at this window, and there is an input gain and there is an output gain. Input gain is set at 24 decibels. Output gain is set at negative 18 decibels. And I also have Audacity open, so I was thinking about recording a sample audio set at 16-bit or 24-bit, also set at 44,100 kilohertz. You could also set it at 48 kilohertz or 96 kilohertz. But yeah, I was viewing this. So we can view the audio settings over here. We have core audio. I have my device set as the Volt 276 by Universal Audio. Great audio interface, by the way. And the device is also the Volt 276 set at 44.1 kilohertz, and the default sample rate is 32-bit float. I think what we can do is set it at 24-bit. These days, 16-bit quality is CD quality, 24-bit is the typical for any recording project these days on the computer. I'm going to hit OK. And I've got my guitar here, and we're going to set the metronome to any old pace, probably, let's do 100 BPM. Okay, so I've got a beat, or I've got a rhythm actually, and we're gonna take the guitar pick and we're gonna record something. 1, 2, 3, 4. Okay, and then I'm going to set this at a reasonable start point. Okay, so never mind. Delete this tail end right here. And delete some of it. I think there's some distortion. clipping. It was clipping before, so I'm gonna set it playback level to like 87%. Okay, and then I'm actually going to export this. Export audio to computer, and we're going to title it Test Guitar Overdrive. Clean to Overdrive. Okay, how about a clean signal? Test guitar, clean signal. Export. We're going to minimize this screen on the right side. I'm going to expand this window, and then we're going to drag and drop it into here. Okay, and now I'm viewing the C++ code. These are the .c++ and the .h files for the overdrive effect. And I have no idea why the font is so unviewable. However, I can honestly say that I do not know what the code does. All that I know is that it performs certain mathematical actions onto the signal itself with digital signal processing, or DSP, and we are able to clip the sine wave signal, so to speak, into a square wave signal. And there's a structure here. There is a gain variable. There's a bias variable. There is a main.cpp, or a main, what do you call it, function, and then we're able to clip the signal. The other day, I was doing my best to explain, from my current level of understanding, the invention of the light bulb and how it in turn affected the invention of the vacuum tube, and from the vacuum tube later on to the transistor. Here is a snapshot of a light bulb, an incandescent light bulb, pictured next to a 12AX7 dual triode vacuum tube. And just as before, I'm going to take the guitar signal and drop it into the demo runner over here, the demo code and GUI for this overdrive effect. And notice there's an input gain and an output gain. We're gonna have a listen to the loop. I'm gonna loop the file, and then we're going to press the space bar, and this is what it sounds like. Input gain 24 decibels, output gain minus 18 decibels. And play. Whoa, that's going in very hot. I'm going to turn it down, the input gain. Okay, that was way distorted. I didn't mean to distort it so much. Oh, okay. Let's turn up the output gain without turning up the input gain. I think that will turn up the decibels without distorting it. Isn't that interesting? I'm now viewing a datasheet of a 12AX7, which is otherwise known as twin triode. And triode, as it suggests, is an element with three elements: an anode, the positive end, the cathode, the negative end, and the grid, or where the signal enters the vacuum tube to be able to amplify the rest of the signal. And I thought this was pretty interesting. It's pretty fascinating to read through this data sheet and learn about the technical and historical information on this device. A figure of the bottom side and the schematic of the twin triode that can be better explained. After viewing either the datasheet or the schematic of the twin triode, we can see that it is indeed a dual chamber or dual element device with two anodes, two cathodes, two heater elements to loosen the electrons from the cathode, and two grids in two individual chambers. When working with this device, at first I thought that you could have a stereo or dual mono device being amplified. However, what typically happens is, since we were reviewing the digital overdrive or digital distortion, in which there's an input gain and an output gain, typically what happens is that the one stage of the triode will cascade or in series be connected to the next stage of the triode.